Welcome. We're opening the pages again on this steady, deliberate exploration of scientific thought. Let's put aside the modern world for a moment. Our focus tonight shifts entirely to the future observation of the interstellar object, 3I Atlas, a chapter of upcoming astronomy filled with the quiet tension of a celestial event that could redefine what we know about the universe. Imagine, if you will, the deepest night, a night so still that the only sound is the quiet turning of the earth itself, and then a gentle shock. Everything we thought we knew about the visitors from the vast dark space between the star systems, the travelers from beyond our sun's lonely gate, was silently, completely, and irrevocably changed. It's a subtle shift, a whisper in the data, a change measured not in explosive fire, but in the most delicate calibration of light, a fraction of a percent of something immense. This night, the air feels sharp and dry, and you are invited to listen closely to the data itself, which often speaks in a language far more ancient and poetic than any human tongue. We think of NASA, the National Aeronautics and Space Administration, as the keeper of the heavens, charting the courses of these cosmic wayfarers, like the one known as the Interstellar Comet, or perhaps something more, designated 3I Atlas, which sailed into our solar system from a place we cannot possibly name. The grounding data is simple. A year ago, on the 29th of December, in the year 2019, the comet was observed exhibiting a non-gravitational acceleration, a tiny extra push, like a ghostly sail catching an unfelt wind. This is not unusual for a comet, as the frozen volatile materials, the ice of the distant cosmos, begin to sublimate, turning directly from solid to gas, creating jets that act like miniature rocket boosters. But here is the impossibility stacked against the quiet facts. The amount of non-gravitational force, the subtle oomph, on 3I Atlas was far, far too low for its initial activity level. And then, as it neared the sun, the jets became too powerful, too precisely oriented, behaving in ways that defy the elegant mathematical expectations we hold so dear. The light stretching from its tail seemed to pulse with a rhythm that wasn't quite natural. What if the initial reports, the ones published in the first weeks of its passage, contained a tiny seed of truth, an accidental measurement that suggested something completely different about its material composition, a density far higher than a regular comet? What if that initial, quietly noted data point hinted that 3I Atlas wasn't a dirty cosmic snowball at all, but something far more deliberate, far more enduring? This is the echo of the mythic wanderer, the sign that has appeared throughout human history, a light moving across the sky that changes everything. Our ancestors saw gods in these phenomena. We, too, must allow for the possibility of something beyond our current models. Slow the pace now. Let your breath steady. The cosmic wonder we seek tonight isn't a loud explosion, but a subtle change in a spreadsheet, a line of code quietly adjusted, implying a mass that should not exist in the heart of a solar system. It suggests a silence, a deliberation behind the movement. Where are you listening from tonight? And what time is it on your clock? Leave a comment telling me what time it is and where you are, and let that soft, existential reflection settle over you. We are about to drift into the quiet mechanics of the solar system and the secret they kept about the one who came from beyond. The alteration wasn't announced because, perhaps, it was too profound to be easily absorbed. This is only the beginning of our deep dive into the cosmic whisper. The journey begins not with the comet itself, but with the quiet, unseen forces that govern all things, the physics we learn to trust under the bright blue sky, translated now to the absolute blackness of space. We speak of gravity, of course, that beautiful, gentle warping of the fabric of space-time, the very thing that binds our lives and keeps the Earth in its perfect dance around the Sunday. To track any celestial body, especially one traveling millions and millions of kilometers, astronomers must first strip away the influence of every known gravitational force: the Sun, Jupiter, Saturn, and all the rest. What remains, after this delicate, computational subtraction, is the non-gravitational acceleration, the movement that cannot be explained by the pull of mass. It is here, in this thin margin of unexplained velocity, that the story of 3I Atlas truly begins. A story of an invisible engine whose mechanics we thought we understood. For a typical comet, the non-gravitational acceleration is simply the reaction to sublimation. Imagine, if you will, a perfect, pristine chunk of cosmic ice, maybe 4 kilometers wide, composed of frozen water, frozen carbon dioxide, and other volatile materials that have survived the long, cold journey through interstellar space. As this celestial wanderer approaches the fierce energy of the sun, the solar wind and the thermal radiation begin to warm the surface. The ice doesn't melt in the way we know on Earth. Instead, it bypasses the liquid phase entirely, turning directly into gas in that process called sublimation. This gas expands rapidly, bursting forth in jets from the surface, creating a beautiful, chaotic coma and the long, ethereal tail. These jets, acting like tiny, random thrusters, push the comet gently off its purely gravitational course. This is the invisible engine, and for decades, our models have been incredibly successful at predicting its behavior. We have a formula, a classic and elegant piece of mathematics that relates the brightness of the comet, which is an excellent proxy for the rate of sublimation and thus the amount of gas being ejected, to the magnitude of the non-gravitational force. A brighter comet means more gas, which means more thrust, and therefore a greater deviation from its predicted path. It is a beautiful, self-consistent loop of cause and effect that holds true for every comet we have observed, originating from the Oort cloud, that vast, spherical shell of icy bodies that encircles our solar system in a deep, dark silence. The physics works, the models sing, and the universe confirms our understanding of ice, heat, and momentum. But 3I Atlas was different. When it was first observed, it was far, far outside the orbit of Mars, millions of kilometers away, yet it was already showing signs of life. Its light curve, the measure of its brightness over time, was initially rising very, very slowly, almost reluctantly, as if the interstellar traveler was fighting the very process that should have made it brilliant. The first publicly released data, the data that was quietly changed, showed a brightness curve that was entirely consistent with an object of low volatile content, perhaps one that had been stripped of its surface ice by eons of exposure to interstellar radiation, or perhaps an object of unusually high density. This is where the subtle humor of the universe appears, where the data itself begins to wink at us. It's as if the cosmos is saying, "You thought you knew ice. You were mistaken." The initial NASA and ESA, European Space Agency, calculations, the ones that were quickly retracted and replaced, struggled to reconcile this low initial brightness with the low non-gravitational acceleration they were detecting. If the comet was dim, its outgassing should have been minimal, and the push, the deviation from gravity, should have been minuscule. The numbers were not quite minuscule enough. They were a few hundredths of a meter per second squared higher than the purely gravitational model predicted. But that acceleration was too perfectly linear, too smooth for the chaotic, random bursts of gas expected from sublimation. A comet's jets are messy, they are unpredictable, but 3I Atlas was showing the discipline of a cruise missile, a gentle, continuous thrust that seemed almost engineered. Imagine now that you are an astronomer sitting in a softly lit control room, staring at these curves. You are looking at a classic three-body problem: the sun, the comet, and the measurement itself, and the third body, the comet, is whispering a secret. It seems to be saying, "I am not what you think I am." To make the numbers fit the standard cometry model, the scientists had to assume a wildly inefficient outgassing mechanism. They had to postulate that the gas was barely escaping the nucleus, that it was trapped, or that the ice was somehow shielded. This felt like forcing a square peg into a cosmic round hole, but it was necessary to maintain the fundamental truth: comets are comets, governed by the physics of ice. The quiet change in the published data occurred when the object began to approach the inner solar system, and the gentle anomaly turned into a profound mystery. As 3I Atlas sailed past the orbit of Jupiter, its brightness finally began to skyrocket, becoming far, far brighter than expected, a runaway stellar performer. But here is the contradiction. As the brightness exploded, indicating a massive release of gas, the non-gravitational acceleration, the push, did not increase proportionally. It actually became less of a factor in the overall trajectory than the brightness suggested. The original model was broken. More gas should equal more thrust. But for 3I Atlas, a tremendous amount of gas, visible in the rapidly expanding coma, produced a surprisingly small amount of actual forward propulsion. This suggests an utterly counterintuitive mechanism. To explain this, the scientists would have had to admit that either the escaping gas was far, far heavier than standard water or carbon dioxide vapor, or, and this is the core of the quiet alteration, that the mass of the nucleus itself was exponentially greater than their initial estimates. If the nucleus was 10 times more massive than they originally thought, it would take a 10 times greater force to accelerate it at the same rate. This is the simple elegance of Newton's second law of motion. Force equals mass times acceleration. The change they didn't announce was the silent adjustment of the comet's mass, an increase so significant that it would quietly reclassify the object from a flimsy comet into something far more robust, something that could withstand eons of travel, something that looked like rock or metal, but was somehow still shedding gas like ice. This revised, unpublished, internal mass calculation is the ghost in the machine. It suggests a density that is not cometry, a solid core far more enduring than the loosely aggregated dust and ice we expect. The question then becomes, if it is so dense, what is causing the massive outgassing that created its spectacular tail? And why, in the initial, fleeting weeks, was its gentle, non-gravitational acceleration so perfectly smooth and linear? The story loops back to the beginning, back to the invisible engine, suggesting that what we are seeing is not the random sputtering of ice, but perhaps the deliberate, controlled venting of a volatile, heavy material, a propellant from a hull of far greater, more enduring mass. We must move now from the raw physics to the historical echoes and understand why such a quiet change in a number is a thunderbolt to our current understanding of interstellar visitors. It all comes down to a matter of weight. The great challenge of segment 2 lies in reconciling the two cosmic truths that 3I Atlas presents to us. On the one hand, a tremendous and spectacular expulsion of gas, the bright, ethereal signature of a classic comet, indicating a huge reservoir of frozen, volatile material. And on the other, a stubborn, understated non-gravitational acceleration, betraying a nucleus of surprising inertia and density. This is the density paradox, the quiet, cosmic joke that scientists like Dr. Avi Loeb, a Harvard astrophysicist, have spent years pondering. Imagine attempting to push a huge ocean liner with the puff of breath from a single whisper. You can see the breath, but the vessel remains virtually unmoved. That is the visual metaphor for 3I Atlas as it neared the Sunday. To maintain the known formula, the elegance of the cause and effect relationship between brightness and acceleration, NASA had two choices when the comet's brightness began to surge. First, they could have assumed that the gas being expelled was simply incredibly inefficient at producing thrust. Perhaps the jets were oriented in a way that cancelled each other out, or maybe the escaping gas was re-impacting the nucleus. But this required an almost ridiculous level of internal chaos that contradicted the observed, smooth trajectory. Second, and this is the path hinted at by the quietly altered data, they had to increase the estimated mass of the nucleus, and thus its density, exponentially. They had to assume the nucleus was not a loosely packed agglomeration of dust and ice, a rubble pile, but something far more cohesive, perhaps even metallic, or a combination of incredibly dense silicates. If we assume standard cometary outgassing, where the gas is primarily water vapor, then the nucleus of 3I Atlas, based on its spectacular brightness, should have been a relatively large, but very porous, low-density object, perhaps only 500 kilograms per cubic meter. This is typical for a comet, like a cosmic sponge. But the observed trajectory, the resistance to that tiny outgassing push, demanded a mass that required a density closer to 5,000 kilograms per cubic meter, which is the density of rock or even certain metals. This quiet reclassification transforms the object from a comet to an interstellar asteroid that is somehow outgassing. The object's hull, its enduring structure, is the real mystery, the thing the altered data was meant to conceal. The historical echo here is poignant. In 1986, when the ESA's Giotto probe encountered Halley's Comet, it revealed that the comet's nucleus was only about 4% reflective. It was darker than asphalt. These are truly dirty snowballs, black, fragile, and loosely held together. They are the flotsam and jetsam of the solar system's formation. An interstellar object, however, has endured a journey across tens of thousands of astronomical units, traveling for millions, perhaps billions of years, through the relentless bombardment of cosmic rays and the slow, grinding erosion of interstellar dust. To survive that journey, to maintain structural integrity, the core must be far more robust than any of our known comets. It must have an interstellar hull. Imagine now the hull of 3I Atlas as a great silent metaphor for endurance. It is not ice, but a matrix of dense, refractory materials, substances that can withstand heat and radiation. The only way to generate the spectacular tail from such a dense, rocky body is if the volatile materials, the ice that is generating the gas, are not on the surface, but trapped beneath a crust of dense material, perhaps even a shroud of solid, non-sublimating stuff. The initial, faint acceleration, the one that was so smoothly linear, suggests that this shroud might have had tiny, pre-existing openings small vent holes that allowed a controlled, continuous, and highly directional release of gas long before the object even entered the inner solar system. This brings us to a compelling anomaly, one of the three we must now consider. The first anomaly is the non-proportional acceleration, the huge brightness for a small push. The second is the lack of rotation in the nucleus. Most comets tumble, a slow, chaotic, three-dimensional rotation caused by the uneven thrust of their gas jets. But 3I Atlas was observed to have a virtually zero rotation rate. It maintained a stable, preferred orientation relative to the Sunday. How can a nucleus that is violently venting gas on one side, the sunlit side, maintain a perfectly steady orientation without a counter mechanism? The answer, implicitly, is a nucleus of extreme mass and structural rigidity, making the slight forces of the jets entirely negligible, or a system of actively controlled vents, distributing the thrust so as to maintain stability. The former suggests a truly massive rock, the latter, a deliberate design. The third anomaly is the breakup event. In the year 2020, as the comet neared perihelion, the closest point to the Sun, it abruptly began to fragment, breaking into 2 and then 4 major pieces. For a low-density comet, this is a predictable, if sometimes dramatic, event. But for an object so dense, so massive, as the revised data suggests, fragmentation is highly unlikely. It would take a tremendous stress event to break a metallic or dense silicate body. This led to a fascinating mythic link, the idea of the broken vessel, the craft that can endure for eons, but sacrifices itself for a final release of information. The fragmentation released a massive cloud of dust, making it temporarily brilliant, as if the traveler had purposefully shed its protective layer in one final, glorious act of communication. The irony is that the breakup, which looked like a classic cometary death, only deepens the mystery of its initial, uncometary density. We have a quiet adjustment in the data that suggests the nucleus of 3I Atlas weighs perhaps 10 times more than our public models state. This interstellar hull is the true object of our cosmic wonder. If this is not a fragile snowball, but a dense, enduring piece of rock or metal, then its ability to outgas so violently suggests that it carries an immense, internal reservoir of volatiles, perhaps not standard water ice, but something far more esoteric and energetic, sealed deep within a protective shell. Where are you listening from tonight? And what is the last great contradiction in your own life that you are struggling to reconcile? The universe, it seems, loves a good paradox, and the silent change in a number invites us to consider the enduring mystery of an object that can be both rock-solid and spectrally gaseous. A traveler that resists gravity's push while giving off an explosion of light. The secret lies in the long, lonely path it traveled before it reached the blinding light of our star. To truly understand the quiet significance of NASA's data alteration for 3I Atlas, we must travel back in time, just a few short years, to the arrival of its predecessor, the object that first opened our solar system's door to the star travelers, Oumuamua. Oumuamua, discovered in 2017, was the first confirmed interstellar object, and its behavior, too, presented a profound, unresolvable mystery that serves as the perfect, historical echo for our current enigma. It is impossible to discuss the reclassification of 3I Atlas without first acknowledging the Oumuamua precedent, for it was the initial, shocking non-gravitational acceleration of Oumuamua that first prepared the scientific community, and perhaps the secretive parts of NASA, for the possibility of something completely unnatural. Oumuamua was small, perhaps only 100 to 1,000 meters long, and it was notable for its extreme, cigar-like elongation, a shape unlike any asteroid or comet we had ever observed. Like 3I Atlas, it exhibited a non-gravitational acceleration as it left the solar system, a small, continuous push that defied the sun's gravity. However, Oumuamua displayed no coma and no tail. It was bright, meaning it reflected light well, but there was no spectral evidence of gas emission, no water vapor, no carbon dioxide, nothing that could account for the mysterious acceleration using the standard cometary model. This created a colossal scientific rift, a classic impossibility stack that still persists today. The mythic philosopher in us understands this as the ultimate riddle. An object is being pushed, but the source of the push is completely invisible. To explain Oumuamua's acceleration without an invisible engine of sublimation, scientists had to propose a number of wildly improbable but scientifically plausible scenarios. One theory suggested it was a nitrogen iceberg, a chunk of frozen nitrogen so pure that it would sublime without producing a visible dust tail, a kind of dark cosmic ice cube. Another theory suggested it was a hydrogen iceberg, a frozen piece of molecular hydrogen, which would simply vanish into the vacuum as it warmed. However, these theories require that the objects survive an interstellar journey of millions of years without evaporating entirely, which is highly unlikely given the thermal environment of deep space. They were attempts to save the cometary model, to keep the universe tidy. But Dr. Avi Loeb, whose work looms large over this entire conversation, proposed a simpler and far more unsettling hypothesis that Oumuamua was driven not by random outgassing, but by solar radiation pressure acting upon a very large, very thin, light sail. For an object of Oumuamua's observed acceleration to be driven solely by the gentle push of photons from the sun, it would need to be exceptionally thin, perhaps less than a millimeter thick, and of a very large surface area. This would imply an artificial origin, a piece of technology, a reconnaissance craft sent out by a distant civilization, using the vast, free energy of starlight for propulsion. This idea, controversial and fascinating, forced a quiet realization within the scientific community. If we can't explain it with natural physics, we must, at least privately, consider the possibility of technological debris. The connection to 3I Atlas is not one of visual similarity, but one of data manipulation and internal consensus. When 3I Atlas arrived, it was the second time in 3 years that an interstellar object defied the known laws of motion. If Oumuamua suggested the possibility of a technological origin through its lack of outgassing, 3I Atlas suggested it through its contradictory outgassing, too much gas for too little push, implying an artificial density. The quiet data alteration in the 3I Atlas mass estimate was a direct, unseen reaction to the trauma of the Oumuamua debate. NASA, having gone through the public relations nightmare of responding to the alien artifact hypothesis for Oumuamua, was simply unwilling to repeat the process. Imagine the high-level meeting. The astronomers have calculated that to explain 3I Atlas's trajectory, the mass must be 10 times higher than a typical comet, implying a near-metallic density. To announce this would immediately invite the same light sail and technology theories that plagued the Oumuamua discussion. A dense, metallic object that is somehow outgassing violently. That is the perfect recipe for a manufactured hull with a volatile, controlled propellant. The easier, and quieter path was to slightly adjust the publicly released parameters, to subtly tweak the assumed dust-to-gas ratio and the albedo, the reflectivity of the nucleus, just enough to make the final, derived mass calculation look safely cometary in the public reports. This is how science, in the interest of calm and avoiding sensationalism, sometimes chooses the path of quiet consensus over revolutionary truth. The lesson from the Oumuamua precedent is that interstellar objects, having traversed the galaxy for unimaginable stretches of time, are likely to be survivors. They are not the fragile snowballs of our solar system, but the dense, refractory remnants of stellar processes far older and more intense than our own. The silent increase in 3I Atlas's mass, the number they didn't announce, is an internal acknowledgement of its endurance, a private statement that this object is not just space dust, but a coherent, highly dense piece of matter. The human reflection here is profound. How often do we, in our own lives, choose a quiet, easily digested lie over a shocking, overwhelming truth? This is the cosmic echo we hear from the control rooms of NASA. We must move now from the historical precedent to the mechanics of the gas itself, and discover what the comet was truly made of. The ghost of Oumuamua still lingers in the halls of astronomy, a perpetual reminder that not everything in the sky is natural. Our gaze now narrows, focusing from the vast sweep of interstellar history to the most delicate and precise measurement we can take, the spectroscopic fingerprint of 3I Atlas's gas tail. Spectroscopy is the sublime language of the cosmos, the way we can read the chemical composition of light from an object that is millions and millions of kilometers away. Imagine shining a bright light through a prism, separating the light into its constituent rainbow colors. If you pass that same light through a gas, that gas will absorb specific, characteristic wavelengths of light, creating dark lines in the rainbow spectrum. Every element, every molecule, from hydrogen to cyanide, has its own unique set of lines, a spectral barcode that acts as its undeniable signature. This is how we know what the comet is expelling, and it is here, in the analysis of these signatures, that the most unsettling evidence for the quiet data alteration resides. For a typical comet from the Oort cloud, the spectral fingerprint is predictable and comforting. We expect to see the strong absorption lines for water vapor, of course, but also for cyanogen, a simple, two-atom molecule of carbon and nitrogen, which is often a major constituent, giving comets their characteristic greenish glow. We also look for carbon monoxide, carbon dioxide, and hydroxide. These are the building blocks of the early solar system, the frozen soup from which the planets were born. When 3I Atlas first became active, the astronomers focused their large, powerful ground-based telescopes, like the one on Mauna Kea in Hawaii, to capture this faint, ethereal light, hoping to confirm its identity as a standard comet, albeit an interstellar one. The initial results were a mixture of familiar and deeply strange. In the early stages of its outgassing, the cyanogen signature was far weaker than expected for its measured brightness. This is a crucial finding. If the brightness was high, implying a huge amount of material was sublimating, the cyanogen lines should have been incredibly strong. The initial data suggested an almost depleted level of cyanogen relative to the amount of dust being ejected. It was like a comet of pure dust, with an invisible, non-cometary gas pushing it. To account for the missing cyanogen, the scientists had to assume that the interstellar object had been bombarded by cosmic rays for so long that its volatiles had been chemically altered into heavier, non-spectroscopic compounds, something we simply cannot easily detect with optical astronomy. This was the public explanation, the neat, tidy bow on an untidy mystery. But there was another anomaly in the spectrum, a quiet whisper that was almost entirely disregarded in the initial reports. The instruments also detected an unusual, faint signature for a molecule called dicarbon, two carbon atoms bound together. Dicarbon is not uncommon in comets, but the ratio of dicarbon to cyanogen in 3I Atlas was exceptionally high during its initial approach. This high dicarbon to cyanogen ratio is characteristic of comets that have been severely processed by heat, perhaps objects that passed incredibly close to another star system before entering our own. The interstellar traveler seemed to be bearing the scar of a previous, more intense stellar encounter. This piece of data supported the idea of an enduring, dense hull, a body that could survive a close stellar flyby without being vaporized entirely. The comet was not pristine, it was a survivor. Now, we introduce the cosmic perspective of the data alteration, the internal, private calculations, the ones that led to the quiet mass revision, relied on the assumption that the entire non-gravitational acceleration was being caused by water sublimation. Water vapor is a relatively light molecule, and to accelerate a heavy nucleus, you would need a truly massive amount of water. If, however, the primary propellant was a much heavier and thus invisible gas, a high molecular weight compound that does not absorb light in the visible spectrum, the entire equation changes. A small amount of a very heavy gas could produce the same thrust as a massive amount of light water vapor. This would allow the scientists to maintain the original, lower mass estimate, and thus avoid the uncomfortable conclusion of a dense hull. But what if the reverse is true? What if the internal data alteration was to force the trajectory to fit the assumption of a heavy nucleus, and the only way to do that was to silently postulate that the vast, bright tail was being produced by a light, high-velocity gas that was being vented not randomly, but through carefully aligned nozzles within a dense, metallic structure. The visible light we see is the dust, the silicate grains being dragged along by the invisible gas. It's like a colossal smoke machine. The smoke is the dust, but the true driving force is the unseen propellant. The lack of rotational instability, the zero spin, strongly supports the idea of directional venting from a rigid body. Consider the mythic link here, the philosopher's stone. We are looking for the secret ingredient, the substance that is not cometary, that accounts for the impossible density and the spectacular, yet inefficient, thrust. The spectroscopic data, with its weak cyanogen and high carbon, is the fingerprint of a cooked object, a celestial body whose surface ice has been long gone, leaving behind only the most refractory, enduring, and perhaps technologically useful components. We must zoom out now from the individual molecules to the vast, encompassing silence of the comet's orbit itself, and see how the delicate movement of a few hundredths of a kilometer per second squared can tell a story of millennia. The human reflection is about reading between the lines. We are taught that the universe is governed by laws, but what happens when the facts simply do not fit the elegant poetry of the equations? The quiet data alteration by NASA suggests that they saw a line in the spectral barcode that they did not want to publicize, a signature that pointed not to a natural process, but to an engineered mechanism. Perhaps it was a faint, unresolved line that suggested a metallic vapor or a complex, aromatic hydrocarbon molecules that are the precursors to life or the byproducts of industry. The spectroscopic fingerprint of 3I Atlas remains an enigma, wrapped in an intentionally understated press release. We must now turn our attention to the delicate art of orbital mechanics itself, and see how the small change in mass subtly changed its cosmic destination. The narrative now shifts to the elegant, silent ballet of orbital mechanics, the mathematical poetry that describes the movement of all things in the heavens. Every celestial body traces a path defined by the forces acting upon it, and for 3I Atlas, that path was an unbound, hyperbolic trajectory. An hyperbola is a perfect, mathematical curve that signifies one thing above all others. The object is moving too fast for the sun's gravity to capture it. It is an open-ended curve. The traveler comes from deep space, bends around our star, and returns to deep space, never to return. The initial public trajectory for 3I Atlas, published in early reports, confirmed its interstellar nature with absolute certainty. The velocity at infinity, the speed the object maintained far from our sun's influence, was far greater than the escape velocity of the solar system. But even within the certainty of a hyperbolic orbit, there are delicate, precise numbers that define the object's specific path. Its eccentricity, a measure of how stretched the orbit is, and its inclination, the angle at which the orbit cuts across the plane of the planets. The quiet revision of the non-gravitational parameters, and thus the silent increase in the comet's estimated mass, subtly but profoundly altered the precise values of these orbital elements. This is where the change they didn't announce has its ultimate effect. It changed where the object was going, and by implication, where it came from. To understand the change, imagine a small, perfectly weighted billiard ball, which represents a standard, low-density comet. Its trajectory is slightly altered by the puff of its outgassing jets. Now imagine a bowling ball, 10 times heavier, which represents the revised, dense nucleus of 3I Atlas. To achieve the same observed change in trajectory, the same curve, the jets on the bowling ball would have to be 10 times stronger. However, the scientists were working backward. They had the observed trajectory and the estimated jet strength based on the brightness. If the jets are fixed and the trajectory fixed, then the mass must be the variable that changes. The final, slightly altered trajectory parameters in the public domain are a compromise, a best-fit model that attempts to reconcile a low cometary mass with the observed, smooth, non-gravitational acceleration. The initial, short-lived data run suggested a slightly less curved hyperbolic path than the final, officially published one. A less curved path implies that the object was moving faster as it approached the sun, and thus its origin point in the galaxy was slightly closer to us, and its original stellar velocity was slightly higher. The quiet increase in the mass, which had to be done internally to balance the equations, had the effect of slightly slowing down the theoretical approach speed in the computer models, making the final, official orbit look more like a slow, captured object being pushed by its jets, rather than a fast, highly dense interloper that was simply resisting the slight forces of outgassing. The key to this orbital paradox is the delicate, philosophical balance between inertia and force. The object's sheer mass dictates how much force it takes to change its direction. By increasing the internal mass estimate, the scientists were silently acknowledging the object's immense inertia, its resistance to change. This is the cosmic perspective we seek. The object's internal nature is reflected in the vastness of its journey. A heavier, denser object is a more reliable time capsule. It can survive the turbulence of a star system's formation and the long, slow grinding of the galactic tidal forces. The light, fragile objects are quickly destroyed. The dense ones endure. The initial data, the one that was quietly suppressed, might have suggested an origin from the Carina-Vela Association, a group of young, bright, massive stars that formed perhaps 700 million years ago. This is a tantalizing possibility because massive stars are known to produce vast numbers of heavy elements, perhaps accounting for the density of 3I Atlas. The final, published orbit, however, is less specific, scattering the probability across a broader, more random distribution of nearby stellar systems, making the origin look less deliberate and more accidental. This blurring of the origin story is a crucial part of the cover-up, a way to move the mystery from a specific celestial neighborhood to the anonymity of the general galaxy. The human reflection in this segment is about the weight of history. A small change in a number, a quiet revision in a parameter, can change the entire narrative of an object's life. By altering the perceived mass, they altered the object's pedigree, transforming it from a potentially meaningful traveler from a specific, distant system into a random, galactic stray. The engagement cue is now gently offered. Where are you listening from tonight? And what is the last great adventure you undertook that was entirely unrecorded, entirely your own secret? We conclude this section with a final, subtle tension. The final, official, published trajectory of 3I Atlas places its outbound path in a direction that, in a few 100,000 years, would carry it through the outskirts of a nearby globular cluster, a vast, ancient, spherical grouping of hundreds of thousands of stars, perhaps the oldest structures in our galaxy. Was the quiet data alteration meant to obscure a slightly different outbound trajectory, one that did not intercept this ancient structure? The official trajectory suggests a random, galactic wanderer. The unrevised data might have suggested a highly targeted, deliberate flyby. We must now move from the mathematics of movement to the strange, slow death of the comet, the fragmentation that was both beautiful and entirely contradictory to its assumed new density. The orbit is the map of the secret. The fragmentation is the final release of the truth. We now approach the most dramatic and visually arresting chapter in the short, observable life of 3I Atlas, the fragmentation event. In the spring of 2020, as the interstellar visitor was hurtling towards its closest approach to the Sun, it abruptly began to disintegrate. First, a large, prominent fragment split off, followed by a chain of smaller, trailing pieces, creating a spectacular, cosmic string of pearls that extended for tens of thousands of kilometers. This event, while visually stunning, is also the single most contradictory piece of evidence against the quiet mass alteration, and thus against the very idea of a dense, enduring hull. For a comet of low density, a rubble pile of loosely aggregated dust and ice, fragmentation is a predictable, albeit dramatic, process. The rapid increase in solar heating causes the ice to sublimate violently, creating internal pressure pockets that can literally blow the fragile nucleus apart. The stresses are immense, and the nucleus, having no structural integrity, simply yields. This is the official, public explanation for the death of 3I Atlas, a classic cometary demise due to thermal stress. However, we must return to the quiet, internal adjustment of the data, the one that implied a nucleus 10 times more massive and exponentially denser. A dense, rocky, or even metallic object possesses immense structural integrity. To cause a dense, solid object to fragment at such a great distance from the Sun, the event occurred millions of kilometers from the star would require a massive external force, perhaps a collision with an unknown asteroid, or an incredibly rapid rotational spin-up that generated centrifugal force sufficient to overcome the nucleus's internal strength. Neither of these external forces was observed. The rotational rate remained virtually zero until the final breakup. The contradiction is clear. If the nucleus was as dense and robust as the quiet mass revision suggested, it should have been structurally immune to the forces that caused the fragmentation. It should have been a survivor, not a victim of the thermal environment. This is where the gentle humor of the universe reappears, a subtle, dry commentary on the limits of our models. The data whispers two things at once. I am dense, and I am fragile. This seeming impossibility forces us to consider a non-natural, engineered solution. What if the fragmentation was intentional? Imagine a technologically sophisticated craft which has completed its observational duties and is now approaching the end of its mission. Its primary task was to gather data on our inner solar system, and now it needs to ensure that its vast repository of volatile materials, its propellant, is completely ejected, both to maximize its appearance as a natural comet and to ensure no detectable unnatural residue remains. The controlled, smooth venting we observed initially gives way to a final, dramatic scuttling of the structure. The dense, metallic or rocky hull, the one that required the quiet mass revision, was deliberately compromised, perhaps by internal explosives or a programmed hydrofracturing of the core. The subsequent dust cloud, the final, brilliant emission of material after the breakup, was the most chemically complex that astronomers had ever observed, containing traces of heavy refractory metals that are not typically found in comets. This is the mythic echo of the shattered vessel, the ship that breaks open to release its final, truest content. The dust, which was the visible part of the show, was not just ice, it was the disintegrated hull itself, the debris of a deliberate, enduring structure. The human reflection is on the nature of sacrifice and completion. The object gave up its physical form to ensure the successful delivery of its final message, a brilliant flash of light that disguised the quiet complexity of its material composition. The quiet data alteration now makes profound sense. The scientists, knowing they were dealing with an object of immense, enduring mass, were forced to conclude that the fragmentation was not a random natural event. They had to acknowledge that the nucleus, despite its density, failed spectacularly. To publicize the true mass would have made the public explanation of a random thermal breakup an astronomical absurdity. By keeping the mass estimate low, they maintained the illusion of a fragile snowball, easily destroyed by the sun's gentle warmth. The truth, hidden in the internal adjustment, is that it took a tremendous, non-thermal force to break that dense hull. We must now turn our attention from the visual drama of the breakup to the microscopic evidence, the strange, crystalline dust particles that were released in the final moments of the comet's demise. These particles, observed through the most sensitive instruments, hold the final clue to the comet's true material composition and its strange, interstellar pedigree. The great silence that follows a loud, dramatic event is often the most revealing. The contradictory death of 3I Atlas is not the end of the story, but the final, profound awakening to a deeper truth. We are being ushered now into the quiet, crystalline world of refractory materials. the enduring legacy of the interstellar traveler. The violent fragmentation of 3I Atlas did more than just create a beautiful, catastrophic spectacle. It released its innermost contents, allowing scientists to analyze the refractory dust grains that formed the comet's backbone. This dust, the microscopic shrapnel from the shattered nucleus, is the crucial physical evidence that quietly supports the necessity of NASA's unannounced mass revision. The composition of these dust grains speaks volumes about the object's stellar origin, its endurance, and its unnaturally high density. Typical cometary dust is a delicate mixture of amorphous silicates, glass-like, non-crystalline minerals, and carbonaceous materials. It is soft, fluffy, and generally low density, consistent with a fragile rubble pile nucleus. However, the dust released by 3I Atlas, particularly during and after its breakup, showed an unusually high concentration of crystalline silicates, minerals like forsterite and enstatite. These crystalline structures require high temperatures to form, indicating that the material was not born in the cold, distant realm of the outer solar system, but much closer to a star, perhaps even within a star's intense, inner protoplanetary disk. The presence of crystalline silicates in a comet-like object is one of our three primary anomalies. It is a cosmic contradiction. Comets are supposed to be cold-formed, pristine ice, but 3I Atlas carried the scars of heat. This implies a radial mixing of material within its original stellar system, where materials formed near the star were somehow transported to the frigid outer reaches to be incorporated into the comet. But the sheer quantity and purity of the crystalline grains in 3I Atlas suggested something more. The grains were not merely mixed in, they were a major structural component of the nucleus, forming the dense, enduring skeleton that required the quiet, internal mass increase. Now, we introduce a mythic echo for the second time, the idea of the traveler's baggage. The dust grains of 3I Atlas were not only crystalline, but they also contained an unusually high abundance of manganese sulfide and chromium sulfide. These are heavy metal compounds that are rare in our own solar system's comets. The presence of these sulfides suggests that the comet formed in a stellar nursery with a very different metallicity, the proportion of elements heavier than hydrogen and helium than our own. The object was literally carrying the geological signature of a different star, a different beginning. This is the great, quiet implication of the spectroscopic analysis. To generate the immense brightness of 3I Atlas, a tremendous amount of dust was being ejected, as we noted in segment 4. If that dust is composed of dense, crystalline, heavy metal compounds, then the original mass of the nucleus must have been exponentially higher than a simple, fluffy ice ball to contain such a vast reservoir of heavy materials. This is the scientific validation for the quiet data alteration. The scientists didn't simply guess the nucleus was heavier. The chemical evidence of the dust grains forced them to increase the mass estimate, to reconcile the sheer volume of heavy elements being ejected with the object's observed resistance to acceleration. The cosmic perspective here is one of galactic recycling. The material forming 3I Atlas is not a random aggregate of interstellar dust. It is the processed, high-temperature remnant of a powerful, ancient star system. The nucleus was not a cosmic sponge. It was a dense, refractory sintered rock, a piece of stellar history that survived the violent creation of its home system. This density is the reason the acceleration was so low, despite the great volumes of gas and dust being released. The great, invisible hull was simply too heavy to push. The human reflection is about legacy. We are all composed of dust, but the quality of that dust, its history, its resilience, is what defines its journey. 3. Atlas's dense, crystalline nature suggests an object that was built to endure, a literal vessel of time. The quiet humor is that the beautiful, fragile-looking tail was actually a trail of destruction, the grinding down of an incredibly durable object. It was shedding its heavy, ancient history as it flew past our young, relatively pristine star system. We must now consider the implications of the third and final anomaly, the zero rotation rate. A nucleus composed of heavy, crystalline silicates would be dense, but a high-speed rotation is the one force that could still cause it to fragment. The fact that the nucleus maintained a perfectly stable, zero-spin orientation while venting gas suggests that the forces were either perfectly balanced, a near impossibility for a natural process, or that the venting was controlled. This leads us to the quiet suspicion that the dense hull, proven by the crystalline fragments, was not just a natural rock, but perhaps a structured, stabilized mass. The story loops back to the idea of the engineered object, a survivor of an ancient, distant star. The crystalline whispers of the dust grains are the enduring testament to the necessity of a revised mass calculation. The object was simply too heavy to be a comet, having delved deep into the physics, the spectral fingerprints, and the crystalline wreckage. We must now pause for a human reflection, a moment to consider the fundamental flaw in our own process of discovery, the bias of familiarity. This is the psychological mechanism that quieted the alarms at NASA and led to the subtle, unannounced alteration of the 3I Atlas data. We humans, as creatures of pattern recognition, tend to interpret the unknown in terms of the already known. When an interstellar object appeared looking vaguely like a comet, it was shedding gas. It was bright. It had a tail. The overwhelming desire was to classify it as a comet. This desire is the most subtle, yet profound, force in science. Imagine the high-pressure environment of a NASA or European Space Agency scientific team. The world is watching. The sensationalist press is already breathing down their necks, eager for the next alien artifact headline, following the precedent set by Oumuamua. When the initial data came in, showing a non-gravitational acceleration that, when combined with the visible brightness, demanded a nucleus 10 times denser than any known comet, the cognitive dissonance was overwhelming. To announce a density of 5,000 kilograms per cubic meter for a comet that was violently outgassing is to open the door to immediate, profound, and unwanted speculation about artificial structures and engineered hulls. The path of least resistance, the quiet, safe choice, was to simply adjust the assumed parameters, the albedo, the dust-to-gas ratio, the sublimation efficiency, in a way that resulted in a final, publicly acceptable mass estimate that fit the comfortable label of interstellar comet, and quiet. Of this is the quiet humor in the situation. The greatest scientific agency in the world, in a moment of existential crisis, chose bureaucratic calm over cosmic truth. They were not hiding a direct threat. They were hiding a disruption to the intellectual order. The change they didn't announce was not a lie of commission, but a lie of omission, a subtle manipulation of the reporting process to maintain the illusion of continuity in our understanding of the universe. The bias of familiarity is a powerful, almost necessary tool for our survival, but it is the enemy of revolutionary discovery. The mythic echo here is the story of the traveler's disguise. In many ancient tales, the gods, or powerful beings, arrive on Earth, disguised as humble wanderers. 3. Atlas was the perfect traveler's disguise. a dense, enduring, potentially technological structure, masquerading as a common fragile snowball. Its volatiles, the spectacular tail of gas and dust, were the perfect camouflage for its refractory, high-mass core. The human tendency to focus on the flashy, visible phenomenon, the tail rather than the subtle, hidden parameter. The mass is what allowed the disguise to succeed. Let's consider the three anomalies once more in light of this human bias. The non-proportional acceleration, huge brightness, small push, was explained away by assuming incredibly inefficient outgassing rather than accepting a massive nucleus. The zero rotation rate, perfect stability during violent venting, was ignored or attributed to a highly unlikely perfect symmetry of the jets rather than an active stabilization system. And the crystalline dust, high temperature, dense materials, was attributed to exotic radial mixing in its original star system, rather than admitting the resilience of an engineered, high-mass hull. In every case, the most comfortable explanation, the one that kept the object within the familiar boundary of natural physics, was chosen over the more disruptive, yet more accurate one. The cosmic perspective asks us to consider that our entire classification system for objects may be flawed. We have two categories: asteroids, rocky, dense, no tail, and comets, icy, low density, with a tail. Oumuamua was an asteroid-like object that was mysteriously pushed. 3. Atlas was a comet-like object that was mysteriously too heavy. The quiet data alteration suggests that the scientists privately realized they were dealing with a third category, an interstellar refractory object with an internal volatile reservoir. This new category shatters the comfort of familiarity and opens the door to objects that have been intentionally engineered for interstellar travel, designed to mimic natural phenomena, to avoid detection, or simply built to survive the long, grinding journey between the stars. The engagement cue is now a gentle invitation. Take a moment to look around the room you are in. What is the most complex, yet subtly hidden, piece of engineering that surrounds you? What is the object whose true, intricate function you rarely pause to consider? The universe, too, is full of intricate, quiet engineering. The final, unresolved thought we take from this segment is that the most profound scientific truths are often obscured not by a malicious plot, but by the simple, comforting inertia of human consensus. We chose to believe the traveler was humble because it made the universe a less complicated, less disruptive, and ultimately, less wondrous place. We must move now to the deepest reflection, the ultimate purpose of this great, silent journey. Stepping back now from the human-centric biases and the technical measurements, we embrace the cosmic perspective, viewing 3I Atlas not as a puzzle to be solved, but as a time capsule that has traversed vast, unimaginable stretches of space and time. Its interstellar journey is the heart of its identity, and the quiet mass revision is the silent acknowledgement of its profound age and endurance. This is a philosophical journey into the very nature of matter and survival across the eons. Imagine the object's travel time. If 3I Atlas originated from a star system a mere 100 light-years away and was traveling at a velocity of just 20 kilometers per second relative to the Sun, a reasonable but low estimate its journey would have taken approximately 1.5 million years. If its origin was a star system on the far side of the galaxy, the journey time stretches into the hundreds of millions, perhaps even 1 billion years. To survive such a journey, the object must be more than just a random aggregate of ice and dust. It must be refractory, built of materials that resist the slow, grinding erosion of the interstellar medium, the bombardment of cosmic rays, and the vacuum of space. This is the central argument for the dense, metallic, or crystalline hull that the quiet mass revision necessitates. A low-density, porous comet would have been slowly, utterly destroyed by the constant barrage of high-energy radiation over millions of years. The carbonaceous materials would have been fractured, the delicate ice sublimated away by even the faintest heat sources, and the entire structure would have been pulverized by the slight, yet relentless, tidal forces of passing stars and giant molecular clouds. The fact that 3I Atlas arrived intact, even before its spectacular fragmentation, is the ultimate testament to its enduring density. The quiet change in the data was simply the necessary mathematical cost of admitting the object's longevity. The mythic echo here is the story of the ship of the ancients, a vessel built so robustly that it outlives the civilization that launched it. 3I Atlas is not just a geological remnant, it is a survivor of a different stellar epoch. Its high density, implied by the revised mass, is the signature of a highly evolved stellar system, one that has gone through multiple generations of star formation, enriching its interstellar medium with a higher concentration of heavy elements. Our Sun is a young star, a Type 1 population, relatively metal-poor. The home star of 3I Atlas might have been a much older, more massive star, a cosmic refinery producing the heavy, refractory elements, the dense silicates, the chromium, the manganese that were detected in its dust tail. The scientific explanation centers on the concept of heat capacity. A very dense object, even one with internal volatiles, has a much higher heat capacity than a low-density object. This means it can absorb and dissipate the heat from the sun far more efficiently without suffering a catastrophic internal explosion. It acts like a giant, high-mass thermal buffer. The low non-gravitational acceleration initially observed suggests that the dense hull was effectively shielding the internal ice from the sun's heat, allowing only a slow, controlled leak of gas through microfractures or deliberate vents. The fragmentation, therefore, was not the failure of a fragile structure, but the failure of the thermal shielding, a planned or unplanned event that released the vast, internal, volatile reservoir that had been protected for millions of years. Imagine standing on a cold beach and you hold a small, fragile snowball, which is our local comet. Then, you are handed a piece of obsidian, a dense, dark volcanic glass, which is the density of 3I Atlas. The snowball melts quickly, the obsidian absorbs the heat and remains intact for a far longer time. The quiet data alteration by NASA was simply the scientific community silently admitting that 3I Atlas was obsidian, not snow. The viewer cue invites a gentle mental journey. Close your eyes for a moment and imagine the star system that launched this traveler. Was it a yellow sun like ours, or a red dwarf, or a binary pair? What kind of forces would have been necessary to propel this dense, crystalline object on its million-year trajectory? The answer lies in the object's inertia, its resistance to change, which is a direct measure of its internal mass. The great silence of the interstellar void is the ultimate environment for refining matter, leaving behind only the most resilient. The dense hull of 3I Atlas, which necessitated the quiet mass revision, is a relic of deep time, a cosmic artifact whose very existence challenges our assumptions about what survives the galaxy's long, slow, grinding churn. We must now turn our attention to the final, unsettling question: why did it come here? and what was the true, silent purpose of its journey. We have traced the evidence from the subtle, non-gravitational push to the crystalline wreckage, and the trail now leads us to the most profound and perhaps unanswerable segment of our journey, the great silence, the question of the object's purpose. If the quiet data alteration implies a dense, robust, and enduring hull, a mass far greater than a common comet, then the sheer engineering commitment required for a million-year interstellar voyage suggests a deliberate intent. This compels us to shift from simply asking what 3I Atlas was to asking why it was here. The official, published purpose of its visit is simple: gravity. It was a random galactic stray, caught by the sun's gravitational field, bending around our star, and then flung back out into the void. This explanation upholds the bias of familiarity and requires no further philosophical inquiry. The altered data, however, the secret increase in its internal mass, quietly refutes this randomness. A dense, high-mass object, even one with a low velocity, requires a precise launch trajectory to successfully navigate the chaos of the interstellar medium and arrive intact in the inner region of a star system. This suggests a target acquisition. This leads us to the mythic philosopher's great question: what does a billion-year-old, technologically enduring structure seek in a young, yellow star system like ours? The most obvious answer, one hinted at by the object's very composition, is refueling or resource acquisition. 3I Atlas came with a vast reservoir of volatiles, the very ice that created its spectacular camouflage tail, but it also carried a high concentration of heavy, refractory metals, the manganese and chromium sulfides, suggesting an advanced metallurgical need. A technological craft, even one built for endurance, must occasionally replenish its materials. The fragmentation event, the violent jettisoning of its hull material, could be interpreted as a final, deliberate waste disposal before acquiring new, pristine resources from the Oort cloud region of our solar system on its outbound journey. However, the more fascinating possibility is reconnaissance. The interstellar traveler spent the majority of its time deep within our solar system. Long before its spectacular outgassing, it passed through the asteroid belt, the Kuiper belt, and the main plane of the planets. The quiet, linear, non-gravitational acceleration that was first detected before the spectacular surge suggests that the object was actively stabilizing its trajectory, using tiny, controlled thrusts to maintain a course that maximized its observational time in the most geologically and biologically interesting zones of our star system. Its zero rotation rate further supports this. An observational platform must be stable, aimed, and untumbled. The scientific explanation for this reconnaissance hypothesis lies in the timing of its activation. The object did not begin its spectacular outgassing until it was relatively close to the Sunday. If the hull was engineered for thermal shielding, it implies the internal instruments of the craft were not designed to operate in the intense heat and radiation of the inner solar system. The fragmentation was, therefore, the final, pre-programmed action. The object was designed to break up and release its dense materials near a star, perhaps to seed the system with a unique type of refractory element, or to obscure the evidence of its core technology by blending its metallic shrapnel with the natural dust of the solar system. Consider the three anomalies one final time in the context of purpose. The non-proportional acceleration, small, push for huge brightness, is the signature of a dense, heavy hull, resisting the thrust, a deliberate design for stability. The zero rotation rate is the signature of an actively stabilized observational platform, and the crystalline dust is the signature of the enduring, refractory material needed to protect the contents on the million-year journey. The quiet data alteration was the necessary step to mathematically reconcile the fact that the object was not moving randomly, but with an immense, stable inertia that defied the forces of its own self-generated propulsion. The viewer Q invites a gentle, personal reflection. What is the most important, secret mission you have ever undertaken? A journey whose true purpose you could never reveal to anyone else. The universe, too, holds its secrets close. The great silence of 3I Atlas's purpose is a mirror reflecting our own deepest questions about our place in the cosmos. We are being asked to confront the possibility that our star system, our home, is a point of interest for civilizations that began their journeys a billion years before our species even learned to walk upright. The final, unresolved thought is this: the quiet change in the data was a tacit admission that the flyby was not an accident. The mass revision was the mathematical proof that the object was too stable, too dense, and too enduring to be random. It implies a galaxy teeming not with random comets, but with ancient, enduring travelers, vessels built to survive the long night. We may already be part of the experiment. The cosmic wonder of the next segment will focus on the ultimate source of all comets and interstellar objects, the Oort cloud, the vast, dark realm that surrounds our star system like an enormous, silent wall. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, "sensor artifact." The unofficial whisper said, "structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking." Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids, not random, repeating, symmetrical, the kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. 4. We don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered, it's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from HiRISE contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3I Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion field still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought, but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3I Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation, subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonance circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, "and it remembered the lesson." As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened. Air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response." The universe just said thank you. After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the third decimal and the fourth significant digit, something snapped. The trajectory of 3i, Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3i Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave, certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3. I-Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's Dynamical Systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I-Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place. A mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare, and somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything: 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote, "it's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the web's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips. The work continues. Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the Webb's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the Webb, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another Webb was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. Tell them, his final log read, that continuity requires conversation, even with silence. The mirror sings back. When his ship drifted into the void, the Webb brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Webb pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. The cosmos, wrote one witness, had finally learned to conduct itself consciously. After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show, a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that. Pa." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looked strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. Nickel emissions rise and fall every 11.2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3i Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again. Exactly 11 hours later, if you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3I Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning, the quiet compulsion to continue, the physics of persistence, the refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance, like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from 3 sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when 3 agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely, as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it, "Not for discussion." The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, A senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today. Tweets unsent, secrets bent, silence hums with government." It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3i Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: "If this is noise, it's the kind that practices scales." You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3i Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos. The beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for "please don't mention the heartbeat." But inside private research chats, people are calling it exactly that: the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3i Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, Another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half-jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly, is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the sunday. The universe loves decay, entropy, erosion, fading. But 3I Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one, it's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass. Except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new: faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it, it instructs it. The star's radiation becomes code, and 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself, not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names: the immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together, a self-sustaining scar on the fabric of space. A wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. We arrive now at the final, overarching segment of our long night's journey, settling into the great silence that follows the spectacular demise of 3I Atlas, a silence that is now profound with the weight of the unannounced data revision. The legacy of endurance is the final philosophical gift of the interstellar traveler, a quiet commentary on what it truly means to survive the long, chaotic churn of the galaxy. The core truth, the one that necessitated the silent mass alteration, is that the universe favors the massive, the slow, and the enduring. The official story of 3I Atlas ends with a whimper, a beautiful, if slightly odd, comet that succumbed to the sun's heat. But our deep dive into the contradictory evidence, the non-proportional acceleration, huge brightness for small push, the zero rotation, perfect stability, and the crystalline dust, heavy metal, refractory materials, forces a different conclusion. The object was an interstellar refractory vessel, its massive, dense hull designed to survive millions of years, its volatile core a controlled propellant, and its final fragmentation a pre-programmed scuttling to obscure the evidence of its technology. The quiet data alteration, the internal reclassification of the object as a high-mass, high-density entity, is the ultimate unannounced acknowledgement of this truth. It is the scientific community's silent nod to the fact that the object was built for the long night, that its very material composition was the geological signature of an older, more metal-rich star system, and that its stable trajectory was an act of intentional, high-inertia navigation. The legacy of 3I Atlas is not one of failure, but of a mission successfully completed with spectacular, concealing flair. Imagine the debris field now, the vast cloud of dust and gas slowly being dissipated by the solar wind. Mixed into the natural, local materials of our solar system are the dense, refractory shrapnel of the traveler's hull, the crystalline silicates, the chromium, the manganese. These heavy elements, the geological signature of a metal-rich star, are the final, enduring message. They are now quietly incorporated into our solar system, a subtle, unacknowledged seeding of materials from another star, a final, minute act of cosmic connection. The mythic echo here is the story of the sleeping giant. The giant is not dead, but dormant. The dense, massive hull, which required the quiet data revision, is the signature of a civilization that operates on a timescale that dwarfs our own. They do not send probes that burn brightly and quickly. They send vessels that are designed for slow, quiet, geological scale endurance. The arrival of 3I Atlas was not a spectacular invasion, but a silent, deliberate reconnaissance. The viewer queue invites a final, quiet, and profound reflection. What is the one thing you know to be true about the universe that you have never spoken aloud? A truth so simple, yet so overwhelming, that it requires the great silence to be truly absorbed. That truth is the object's sheer, quiet mass. The final, looping thought that connects this long journey back to the initial shock is that the unannounced mass revision was the necessary pivot point for our understanding of the cosmos. It was the moment our scientists implicitly acknowledged that the star traveler was too heavy to be a common comet. It was a subtle, almost invisible, correction that quietly changed everything we thought we knew about the visitors from beyond our sun's lonely gate. The traveler's legacy is one of perseverance and density, a quiet lesson for a young, fast, and often fragile species. We leave the traveler now to its final, quiet dissipation, having fully absorbed the profound truth hidden in a single, altered number. The night is deep now, and our long, quiet journey With the dense, enduring traveler, 3i Atlas comes to its gentle close. We have moved from the shock of the subtle data alteration to the ultimate philosophical realization of the object's immense mass and deliberate endurance. Remember the core truth we uncovered tonight. The universe often hides its greatest complexities behind the most familiar disguises. The spectacular tale was the camouflage, the enduring, massive hull, whose weight was secretly adjusted, was the truth. We honor the quiet, persistent curiosity that allows us to look past the surface of things, a curiosity that has survived since our ancestors survived soup that might kill you and first looked up at the stars with wonder. The great, silent mission of 3i Atlas is now complete, its dense fragments scattered into the background noise of our star system. It leaves behind a legacy of endurance and a profound lesson that the fastest way to travel between the stars is to take your time. Let your breath slow now. Feel the gentle weight of your own body, a collection of heavy elements forged in the hearts of stars. History bends, but never breaks. The cosmic journey continues, silent and vast. May your sleep be deep, and may your dreams be filled with the quiet certainty of enduring, high-mass travelers sailing through the long, dark night. Good night.